reaction, taking oxygen and adding it to iron, combustion reaction. We have done a single replacement reaction, which is to take magnesium ribbon and put it in hydrochloric acid, and the hydrogen in the hydrochloric acid and the magnesium switch places. And you get the salt, magnesium chloride, and you get a hydrogen gas, which went beep!
Yeah.
All right. Now we're going to do a double replacement reaction. Most double replacement reactions are stinky stupid. This one is at least a vivid color change. Okay? What you need to do is, I'm going to give you two spatulas, two of those wooden spatulas. You're going to take a tiny bit of potassium iodide, put it in a test tube, and put like maybe 10 milliliters of distilled water with it. In a separate test tube, you're going to put lead nitrate in the test tube. Now this is from your lab sheets. And, all right, basically we're going to make solutions with 10 milliliters of water with like a little tiny spatula's worth of each chemical. One in each test tube, separate from the other. Okay? So, somebody get the distilled water. The two test tubes are on the table.
Is this going to be one that you said is real vibrant? I could film it?
Yes.
Okay.
All right, we ready? All right, you've got to like agitate each test tube to get it to stir around. Or you could use one of these to stir it.
I have one of those.
No, one for each. Don't contaminate the test tube. Nitrate ions, which are covalent, swimming around in there as like little molecules, and you have lead as an ion in the water. Remember, we were talking about this. In the other one, you have potassium ions, and you have iodine ions swimming around in the water. Yep. Now, when you add them together, the potassium and the lead are going to change places. Hold it up so that everybody can see. All right, pour one into the other and make sure that they can see the bottom of the test tube. And bingo.
What?
Whoa.
You've now made lead iodide, which used to be made in paint, particularly for school buses.
Oh, really?
And for Caterpillar tractors. And they stopped doing it because the lead paint chips were yummy for the children to eat. And then they get brain damage.
Wow. That's a vivid color change.
It is very vivid. Once again, lead is a transition metal. Transition metals have a tendency to make very colorful compounds, many of which are insoluble in water.
Did you see it, Becky?
Now, the lead iodide is slightly soluble, but you could actually filter that, trap that stuff, dry it, and you would have flake of lead iodide. And if you put that in like oil, you could use that as oil-based paint, which is what people like Michelangelo and Da Vinci did. Okay, so there you go. That's a double replacement reaction where the potassium and the lead change places. The potassium was with the iodine and went with the nitrate. And potassium nitrate is the active ingredient in gunpowder. The lead left the nitrate and went with the iodide, and that forms an insoluble compound. And if you looked in the Regents chemistry reference table, you'd see that lead iodide is only slightly soluble in water. So it forms, if you look now without agitating that test tube, you'll see the solid formed on the bottom. It should start to like settle to the bottom.
Yeah.
Okay, and a little bit will still remain in solution because it is slightly soluble. But if we were to leave that overnight, and we will, it should, well, over the weekend, it should all settle pretty much to the bottom.
Looks like it's still.
And form a solid.
Well, the water won't turn clear again, though, will it? It'll still be yellow?
No, it'll still be tainted a little bit yellow because it is slightly soluble, like maybe, 1 in 100 molecules of it will be in solution because it is slightly ionic.